In physics, very often we add, subtract, multiply, divide physical quantities to arrive at certain results. Now when we make these calculations, for example this addition or subtraction here, if these quantities A and B have errors in them, the calculated value of C will also have some error in it. And we are going to now learn how to estimate the error in a calculated quantity if the quantities used for calculating it have errors in them. Now, to start with, we are learning the rule for addition or subtraction. C is equal to A plus or minus B. Now, C plus minus delta C being the error in C, delta A is the error in B, A and delta B is the error in B. Now C plus minus delta C is A plus minus delta A and B plus minus delta B here. We take A and B out separately, and so we have C plus minus delta C equals A plus minus B plus minus delta A plus B plus delta B. So delta C now is equal to delta A plus delta B. Now mind you, whether it's an addition or subtraction, the final error will always be added. And in estimating errors in this manner, we always add them up. Errors are never subtracted. Now a subtraction of error would actually mean that there is a compensating error. Now what's a compensating error? For instance, if we were adding A and B and there was an overestimate in A and an underestimate in B, the underestimate in B would cancel out the overestimate in A and therefore reduce the overall error. So subtraction of errors has an inherent assumption of a compensating error. Now that would reduce the final reported error. But we can never really be sure that the errors were compensating in nature. What if the errors were both overestimates or the errors were both underestimates and the overall error was actually large? Now, when you're adding, subtracting or multiplying, you never really know if the errors were compensating in nature or cumulative in nature. We therefore report the final error assuming that the errors were actually cumulative and therefore they added up, and by adding up errors we report the maximum error that our calculation can possibly carry. And therefore when we estimate errors like this, we will always be adding up. So let's take a simple example. We have two objects of masses m1 and m2. Those masses are given 10.0 plus minus 0.1, 12.0 plus minus 0.2, and we have to add them up. So the total mass m total is m1 plus m2. When we add these masses 10 plus 12, we get 22.0. The errors are 0.1 and 0.2, and since it's an addition, we'll be applying this kind of a calculation. The error in m total will be the sum of errors in m1 and m2 here. So we just add up these errors 0.1 and 0.2 and we arrive at 0.3. So now we know that total mass is 22.0 and the error in the calculation of the mass, well, the maximum possible error is 0.3, and therefore we report the final result along with the maximum possible error. So the total mass here is 22.0 plus minus 0.3.